Episode 1. Keeping in line with the story, I thought I'd give a bit of background of some of the predictions that Joe made earlier in the year, as a bit of scene setting and also some further introductions to my background and some history for what I can share. So, starting off, I noticed that there was a number of presentations that directly corresponded to some of the topics that we're talking about. So, I just wanted to highlight them here and allow you to go off and have a look at them in your own time. This will give you a bit more background of where my thinking's come from, and it'll also help share some of my experiences. This chapter won't be doing any demos in it, but the next chapter will move on to some practical demos. So first of all, DevOps. This is something that I've been working on for the last 5 years and have a number of presentations on my SlideShare, but some are go into more detail. My thinking has really moved away from the test ops and no ops and SecOps specifics and moved to much earlier in the life cycle around design ops. And I've recently just published a paper on the digital manifesto. Let's move on to the next topics, BDD and TDD. So this has been a focus of conversation for quite a while, and I've had this conversation with people like Dan North in the past. My focus has been really looking at everything just as a single entity or node, and then look at the domain and the context that goes over those nodes so that you can understand them. So my keynote at the British Computer Society covers this in a little bit more detail, also talks about how these complex systems and systems thinking and solutions thinking come together. On to item number 4, from the Selenium 3 release that was this year. Obviously the focus again for the W3C standard is to really using Selenium as a core. Now again, this is just an API, and I think we're moving away from UI automation and see the value of having something which is an overall standard for web automation. My background's coming from doing test automation in the cloud and dealing with more SaaS-based solutions and being able to spin up high-volume automated testing. There's a lot more information around that from my experience of Taz.net, which moves really into this kind of next big predictions around JavaScript being one of those key frameworks. We're seeing this more and more. I've done a number of presentations quite closely with Oracle, and I give a call out to Mikkel, who works for Oracle and heads up their testing tools products. And we spoke at Star East together on the presentation you see in the top right hand corner. We've worked quite closely on not only doing automation for Oracle and Oracle Mobile. We've actually been looking at a lot more complex things around Oats, Flow Builder, Nimbus, and being able to fully automate from a pipeline point of view the Oracle stack, both on-prem and SaaS solutions. Equally, as a bit of fun, when I was out in Brisbane earlier this year, I did a presentation around Doom in line with the new release. So I've spent a bit of time with some of the developers this year. Incidentally, above our office is Blizzard, so I know the Blizzard guys quite well as well. And we're seeing this move towards kind of visual validation. Equally, I will be exploring some of the other OCR-based technologies later on, which include Eggplant and Zaptest. So my big prediction for 2016 was around microcontainerization and Azure Stack. This was a big and bold move by Microsoft to bring Docker natively as part of the Windows stack. Equally, the microcontainerization is around the acquisition Docker did for the Cambridge University startup company Unikernel, which removes the actual requirement for the kernel within the container, which decreases the space considerably. I think it's about 88 meg. So this is a really powerful solution that is no longer OOS. It allows you to support the Microsoft stack, which a large amount of corporates still have in their environments. Equally, this year's been a big focus for me around IoT and what I would classify as enterprise of things, which is bringing IoT to organizations. Equally, I've been involved quite heavily with the testing of those systems, including a smart city project in Copenhagen and a number of other ones across the globe. My other big kind of bid for this year was around microservices and these microservices architectures. I recently spoke at Star West around everything just being a single node, and part of that was the whole world piece for automation engineering, which was it doesn't matter if it's a UI, an API, or a component layer, which I will go into in more detail further in the presentation, but it's understanding the links and nodes and how those services operate, whether that's going from legacy SOA architectures to microservices and microservices with containers, which was the previous slide on micro-containerization. So secondly, the other area which we've started seeing shifts, or there's a prediction, is around this shift right. Now, I don't agree with this particular component because my understanding of shift right is slightly different, is a case of taking information for what's happening in the real world and shifting it across. This is, really when you start focusing on the ARA tools and the APM tools, the application performance management and the application release automation tools that allow you to release into a given environment. You then learn from that environment and pull that information across to understand that environment better. You can, of course, test in that environment, but one of the big ones is the insight. So that's starting to look at things like Splunk, AppDynamics, all those kind of great tools that are sat in that space that are learning about what flows through those links and nodes are happening in the real world. It's also worth mentioning that now we're in a digital world, we're talking about digital experience, which is very different to a single entry, such as a UI. This could be Alexa talking through some kind of AI-based system, talking through a number of machine learning and AI algorithms to come up with what you're trying to say to it. That is a digital experience as much as using a mobile phone, or in the legacy terms, using a browser. Equally, when we start moving into the more complex technology stacks, we move into things like autonomous vehicles. I've been part of doing some Car2X stuff, connected car for a number of organizations, and also Internet of Things based devices such as drones that are autonomous. And I'm sure you've read recently around there using machine learning to understand and recognize objects so they can land successfully. I've been involved with drone technology in Australia for the agricultural areas. Equally, we've used them for all sorts of other exciting applications across Europe. Equally, one of the big focuses that I've been doing this more recently is around VR. So that's your Microsoft HoloLens technology and some of the more widespread mainstream VR solutions that are coming through the pipe. Episode 2. So you're starting your automation career. So you're a young Padawan learning the ways of automation. Now you may have started with a mentor who might have guided you in the right direction, or you might have just gone onto the internet and looked for whatever the latest shiny test automation tool is, or the latest type of framework that's been built in some kind of language which your developers are using. I'm hoping by the end of this chapter that you'll understand that there is always a master and an apprentice, that there is people that have walked this line before yourselves, and there's much to learn in the ways of automation. Equally, you'll probably have understood already that automation is quite a controversial topic. Should everything be automated? Equally, should you be spending a huge amount of time building a test automation framework? Equally, you talk about free tools. Are they free? As soon as you invest time in them, they're no longer free, unless your time is free. Which is why I kind of wanted to put some structure around this. Now, if you've read the latest ISO standard around Part 5, which includes automation, then you might have some understanding of how you do keyword or data-driven approaches, which is still from the early 90s. Or you might be using something like Selenium, which is a W3C standard, as previously mentioned, around doing just browser-based UI. Equally, you've probably seen a number of different types of execution engines, which I'm going to be talking about a number of different ones today. So Telerik, Eggplant, Selenium, Ranorex, the Microsoft Code test, our own execution engine, and a number of others. But one of the things you'll notice is writing automation is very different from automation writing itself. So there's a certain level of maturity that you need to be able to, a journey you need to be able to achieve. Now, this doesn't mean that you need to get to level 5. This means that you may be part of this journey towards these different levels, but you need to understand where the next step is. Equally, should you be taking the next step? If things are working well at the time, you may find that you go backwards. You don't always have to go forwards, because part of it, like when NASA went from CMMI level 5 to level 3, is you don't need sometimes the tools and the process that are just weighing you down. Part of it is things get simpler over time and you can understand them and manage them in a different way. So most of the organizations that I talk to today are probably in between level 2 and level 3. So they're very good at managing it. They've built some kind of tool, automation framework, continuous delivery solution, and now they're trying to really get to that sustaining point of view where they can literally understand and sustain what they're trying to do on a daily basis, not get burnt by the maintenance. However, when you're trying to get to level 4, which I've rarely seen within the automation community, is then when you're starting to understand and predict what you're expecting as the output. Equally, one of the things that I spend most of my time now with customers is in the 5th level around optimizing that. So that's looking at modeling and understanding the probability of what statistical predictability of what you're trying to achieve. So understanding where you are on this journey is absolutely essential. Equally, I've been working with a number of people within the automation community over the last 10 years on around modeling some of these out as a very lightweight assessment to understand where you currently are and where you're potentially struggling. And this could be anything from test data management to how you approach maintenance, for instance. Equally, I don't think it's just one solution fits all or one methodology fits all. And that equally will change per team. So just because one team is using a very heavy automation framework, which might be 5th generation, that doesn't mean that that's going to work for you. Equally, you can't just achieve these things. So if you're trying to get to cognitive adaptive testing, for instance, but you're still quite low on the maturity, then having the ability to predict which tests you need to run and have always on automation that looks at what's failed, works out what's failed, and generates more tests and sends them down the pipe might not be something that you're ready to achieve. So therefore, you might be looking at how you do these in separate instances. So not trying to get there straight away, but looking at what you need to work on and turning them into swim lanes or work streams of effort to get you to that level. Now, there's plenty of good material out there. I mentioned at the start I was lucky enough to contribute to the Experience of Test Automation book. I talk about this, everything that I'm pretty much talking about today in this book around how you address these kind of challenges. Equally, as you can see from the summary on there, I talk about keyword and hybrid and data-driven approaches and frameworks in more detail. Equally, later on, there'll be a Wikipedia link where a lot of this material is being published. The other great source, which comes from Dorothy Graham and also the rest of the automation community, is the Automation Patterns wiki at the bottom of the screen. That, as you can see from the brain map on the left hand side, talks around different types of patterns you can apply to help you on that journey and how each one of those are interlinked with other steps which could either be a process, management, design or execution pattern. Talking of patterns, one of my most recent publications is around a cookbook. The idea behind that is exactly like you'd see with Chef and Puppet, is made up of a number of recipes which you can go off and consume, and they're pretty much agnostic to language. So when I started my career in automation, I started with XRunner and then moved on to WinRunner. So that was in the kind of the late 90s. Now, about 10 years ago, when I presented at one of my first conferences, I looked at all the different tools that was actually out on the marketplace. Now, a lot of these have changed. Ironically, a lot of them no longer exist and have been consumed by another organization. But it gives you an idea that there's a huge amount of different types of tools out there, and they all have different purposes, whether or not you're talking about executable specifications or ATDD, BDT, TDD. Part of it is understanding what that tool and technology does. Equally, I would expect on average over 20 of these tools to exist within your environment that you're currently with. Now, to give you a bit of an idea of today, I had a look at our own internal roadmap of the different tools and technologies we use. My last webinar with Paul Gerard, he's created something called TK Base, which was a knowledge base of all the particular tools and technologies that you can actually use, and that's in the thousands. Here's just a bit of a snapshot of integration which we do at the moment within our landscape, and you'll notice most of those tools are no surprise to you. So Selenium 3, JMeter, JUnit, Perfecto, Cucumber, Ranorex, Appium, all the standard ones that you would expect to see, and there's many more, and we'll be discussing many more throughout this presentation. Equally, I kind of dug out one of my older versions of my CV, which has dated slightly, and looked at all the different tools that I've used over the past. And this is just a snapshot. I think it could have gone on for absolutely ages, but I kind of got bored of adding them all in. But like I said, I started off in the early days with the Mercury Interactive tool sets, and now I pretty much use every type of tool, so kind of becoming kind of tool agnostic, as we could say. Episode 3. Here we see Anakin, soon to be Darth Vader, really mature. He's at the top of his automation framework capability. He's developed things and his powers as far as he can go, and now he's potentially turning to the dark side. This we're going to reflect with the test automation as a service, and talk about how we move beyond testing locally with local frameworks into a kind of a cloud or beyond environment. So when I was asked to last do this, I sat there, and as you can see from this slide deck, I landscaped out all the components that would potentially be required to do a much more scaled automation solution. And later on in this episode, I'm going to introduce a case study of which I'll add some bonus material of going through each one of these components and understanding the tools and technologies that I was using for each component, which are completely agnostic to any particular vendor. But as I wanted to give you a bit of understanding of my background in this area, I wanted to introduce you test automation as a service. Now, this was something that was created in 2010, over 6 years ago, and was built and born on the cloud. In this case, I was lucky enough to have a great developer from the BBC who was able to understand about how we would go about scaling these things, and it was at the early days of Windows Azure platform. So when we built it, in this case, we built, as you can see from the top left-hand corner, we built this on a Flex-based interface, and then we moved it to Silverlight. Obviously, this would be more now WPF and HTML5. But what we started trying to understand is how do we give people a portal so they can self-serve the creation of automation, which is also independent of languages, and also the domain and potential application under test. Equally, test type agnostic, so whether this was performance, this was security, pen testing, or this could be cross-browser testing, whatever it may be, we were able to create artifacts for that particular environment. Equally, we were able to trigger and schedule this as part of a continuous delivery, or per check-in, or at a particular time in the day to be run. Equally, we looked at building an easy to use portal to see what the actual tests were doing, how they are running on the environment across a number of different instances. So this is the early adoption of containers and moving those containers to the cloud, which I'll talk a little bit about now, how I recently do this with Dev Test Labs, but how you move those container technologies so you can scale up. Equally, part of a critical component back then was around dealing with PaaS and infrastructure as a service. So part of our journey towards, configurations code, platforms code, security as code, configurations code was really how do you provision these environments? How do you spin those up? Now, the great thing about using Azure was that we could do this through the VM role technology back in 2010. But now you want to be agnostic. You want to be able to do it in AWS or Google or any Azure. So, part of it is the new challenges, new technologies, but building something that's agnostic to platform was really something that I've been thinking about for the last 6-7 years. Equally, when I talked to Alan Page about this, Alan's written a number of materials and blogs around this. He also was the one of the authors of How Microsoft Test. Now, he defines how you build and mature your framework and test based on whether or not they're relevant, effective, maintainable, efficient, manageable, portable, reliable, or you can diagnose them. And part of it is we built this solution with those components built in. We also won a Google Innovation Award, and we ended up creating it into an open source community. But the example which I'm going to be giving you, as if you want to go and have a look at the bonus material, is around the walkthrough of how all this stuff comes together. So how you do this if you was going to build this yourself, and how each one of those components and each one of those tools would fit into your continuous delivery lifecycle. This is a case study which was written a number of years ago, but it's also very relevant in the sense of how the tools and approaches which you could potentially take to move into kind of high volume automated testing. Episode 3.5. With the recent release of Rogue One, we understand a little bit more about whether or not the flaws in the Death Star plans, or in this case blueprints, was down to an ambiguous requirement designed by a BA, or was down to a feature that was designed by an enterprise architect. Now, my friend recently launched a blog around this particular question of whether or not it was an ambiguous requirement, and how, if they'd have used modeling or user story mapping, they would have got a much more robust, reliable Death Star. Equally, as a bit of fun, to give you an idea of how complex these large-scale delivery programs are, I give you a bit more understanding of how the defining from a particular enterprise architect coming up with the blueprints all the way through to obtaining the blueprints, and then looking at how they then develop and find it and design and deploy, and then we know the result of what happens in the end. Equally, we've seen throughout these episodes a very distinct change of methodology and approach throughout this. Now, this is what I'm classifying as the digital assurance across the entire project, and this can be done in very different styles. This could be the traditional V-model waterfall approach that you would have seen the Empire use and leverage in episode 1, to more of an agile, scaled agile approach that's gone across all the way through to a rogue development kind of developer going off and doing dev anarchy. Partly what I'd like to introduce is the Pocketbook that we've just launched, and you can order a free copy, which you should be able to read within a fly or a commute, and really talks about how you provide assurance across a large scale environment, especially covering things like IoT, drones, 3D printing, and all sorts of other challenges that you might be faced with in your large scale projects. Equally, this book's been on a bit of a tour. Recently, I came back from Silicon Valley, Toronto, and LA and California, where I've been talking to customers who really enjoyed reading through this Pocketbook and felt that it had some really good value for dealing with kind of digital projects. Episode 4, A New Hope. These next 3 episodes are going to be a tribute to the original classic episodes of Star Wars, and also to Carrie Fisher, who recently passed. They will also represent retro automation and some of the valuable lessons that you can learn from the last 3 decades. When I started my journey in the late mid-90s, there was no UI automation. My first taste for automation was an abacus, which was programmed in binary and made various different phone calls between different devices through a PABX. However, I was still testing manually as well, and in this case I was using test management tools such as Test Director, which was released in the early 1995 and looked more like Excel than anything else. The version that I was started on was the early Test Director 5, which was more of a client-server application, but still not made its way to the web-based system which we all know today. I then moved from there to Quality Center, where the introduction of BPTs and also business models, business modeling notation, and then on to application lifecycle management. That's now moved from Agile ALM to Agile Manager, and then more recently, Hewlett Packard Enterprise Octane. But this is just an example of how over 21 years things have changed and progressed. Equally, I think we're all quite familiar now with how we're dealing with things in more of an agile fashion, where we have a Kanban or some type of agile backlog. That might be in something like Rally, that might be in Jira, or that could be somewhere like an Excel spreadsheet or a physical board. One of the challenges which we have is synchronizing all these various sources. So going from a physical Kanban board to a digital one, whether that be in TFS or any of the ones that I've mentioned before, requires you to synchronize between various different sources, either physical or digital. I'm going to give an example next around how you can look at creating models and actually export that, maintain the model and export that into one of these type of tools. So in this demo, we're going to show how we can take a simple model or flow and export that into your application lifecycle management tool or test management tool. So what I've done is I've saved into a generic format, and then I've moved over to my tool of choice. In this case, I'm using HPE Application Lifecycle Management. And what I'm doing is I'm importing that XPDL file, which is the Extendable Process Definition Language, which is just a simple XML structure which could be generated or imported from something like TIBCO Nimbus or BizAgi or Agile Requirements Designer. Once we've got that model imported into our tool of choice, we'll be able to interact with each one of those decision and components. In this particular tool, they're classed as business process tests, which are components within a flow. And as you can see, they're listed there. And what I would like to do is I'd like to create a path, which is a route through those BPT components or what I refer to as a business process scenario. So that path has a number of different routes through the application, which I can select. Once I've selected that particular route or path through the application under test, I can then create a test case or link that to a requirement. So in this case, I have a new flow, and what I can do is I can go into my testing section and look at how I can create a test associated with that flow. So in this case, I'm now just going to generate a simple test, which is a business process test, and then I'm going to link that business process test to a flow. Of course, I could link that to an individual activity or a path, but in this case, I'd like this test to represent a number of steps that have been executed through the tool. So I'm now pulling that in. Equally, I could pull in individual steps, so play music, display error, etc., etc. I can also link a requirement directly to that. So if I go back into my requirement section and I've got my activities, in this case, I talked about play music, I can go through and check which tests link to which flows. A few years later, I was starting to test with UIs. At this point, it seemed worthwhile to join the global initiative of test automation, which had been going on, as you can see from the bottom left-hand corner, since the early days of Windows 3.11. Thankfully, my mentor at the time had been spent the last 10 years building keyword-driven automation frameworks within XRunner and WinRunner. We were now dealing with more complex systems and have a global located team. Most of the team were graduates who worked 9 to 5 on generating flat files, or master driver files to actually power the automation framework, which was managed by the automation architects distributed globally, one within the UK, one in Germany, and one out in Boca in Florida. Now, I'd only started my career early on, and as a bit of a joke, I've added in the shot of Joe, who's at his first conference at Mercury Interactive back in 2002, which was slightly later on than what we're talking about. My first role, as you can see in the middle, was a graduate automation role, so I was lucky to go straight in to doing automation. And as I started, as you can see from the right hand side on my wall, I'd already started working with quite an advanced framework. This framework had already been patented back in 1999. It was quite evolved, and they'd already started using both flat files for doing parameters such as object repository, and also driver files for dealing with test cases and test steps. As you can see from the top right hand corner, this framework was made up with a number of different components. Okay, let's explore this hybrid keyword data-driven automation framework back from 1999. So we start off on the left hand side with the initiation. So this is really checking that everything started and loaded in the background. So in the days of Windrunner, that was CSO libraries, anything that you needed to start up, customized libraries just to get you going. And then we'd move over to the master batch file. The idea here is that you'd start scheduling what kind of execution you'd want to be able to run. So you'd explain which particular tests you were going to execute and which batches of those tests you were going to execute, which then moves us into here. This also included anything application specific that needed to be loaded around that, so that's startup or shutdown. We then went into this more reusable framework component. The idea behind here is instead of passing specific information across, everything should have been loaded by about here. So this is the object main libraries, which was loading the baseline files, which was any parameter files, which was stored in a multi-dimensional array. And in the case of this, it was originally CSV, but moved to Excel, where you'd read in a parameter file, which would contain all the object steps. So in the case of now it's XPath, but back then it would be the primary identifier, which could be a index or a reference within the HTML. So part of that would load all the environment and object attributes into an array, which could be accessed through the framework. Then what you was going to get is you started getting the common functions. These would be for each line of the master driver file. So this driver file would have an expected result, a reference, a pre and post amble action, which would go on within the various different functions. So in this case, the preamble steps would happen first, then any data input and verification, post-amble steps after that, and then verify that what's being inputted is correct. Or this could actually be a step where it checks what's happened in the database. So again, we're passing over parameters, which is the data component, and the keyword component is part of this driver file component. So then we move down here and we've got actions. So these would be broken into the preamble and post-amble actions. So they're reaction checks. So that could be make sure that the box is editable, or it could be do a particular activity such as get the data for that particular input. And then afterwards, that could be checking, could be going off and looking at a function. We'd also have some parameter set and check functionality, which allows you to set a value, check a value, and then make sure that that's the correct information has been put into it. So let's go and have a look at what one of these driver files would look like to give us a bit of context around what we're trying to do. So starting off with the driver file, as we said, there's a reference. In this case, this is a reference to the test director libraries. We have a preamble and post-amble action, and then we have a number of steps. In this case, these are activities which it's like to do, which are linear activities. Equally, we have a number of variables that are launched in at the start, which are around the engine and how we initiate the particular actions. So if I launch Windrunner, at this point I could enable any other add-ins, but in this case we're only going to stick to web testing. For this example, I won't be doing web testing. As you'd have noticed from the master driver file, it's the event viewer. So in this case, we're going to open the master file, which we talked about here, and then we're going to run it. So we're going to run from top. I'm not putting any breakpoints in. Now this is going to load all of those libraries. So object main is what we mentioned, but otherwise we've got the site initiation test, test director interface connection, we've got test director 8.0 loaded on, the application and preamble and post handle actions. Now if I take a quick pause here, I can jump into these actions which have been loaded in. So these are activities and application specific components. So if I scroll to the next one, here's an example of one which is win wait window, where it takes in a maximum time it's going to prepare to wait for a window. It then waits for that window to exist and then enters it, and equally reports out that it has happened. If it hasn't, it captures an image. Equally, we said there were some libraries which were loaded up beforehand. These are the CSO libraries, which were the maths libraries which came with it. We have some test director actions, and we have the preamble, post-amble actions, setting, checking, and then application specific ones. So in this case, I'll be back was a process killer which I used, which terminated any applications which were running. So in debug mode, we're going to run this simple test. So from arrow, it's now going through. I'm going to run on the local host. And all this is going to do is drive a standard Win32 application. And then it'll read through each one of those events which were happening over Christmas. Episode 5, The Empire Strikes Back. This introduces the concepts of probing as an effective way to discover new locations and potential rebel bases. It's also a trap for Han Solo. Again, we've spent the last few decades focusing on creating UI automation when there are two more layers underneath it. Lisa Crispin's pyramid, which is as old as time in itself, explains this in a very simple manner. UI is just the tip, and kind of the challenge around that is moving underneath down to the lower levels, especially at the component level, which is where, when we start talking around DevOps later on, the focus really starts shifting. Last month I spoke at Star West and I talked about world peace for automation. Part of that world peace was saying that everything is just a node, whether that be a UI component, which may be a text box rendered by a DOM, or that could be an endpoint, which is a microservice, which you're connecting to via some kind of API. Part of whatever the challenge is around automation is treating these nodes and links between nodes and where the data comes from the component layer, with the same amount of effort and a time. Equally, moving past the understanding of the three-layer diagram really helps us be able to accelerate our automation efforts. In this episode, we're going to talk about how things changed over that time period. In the early noughties, I kind of started using the automation frameworks at a more industrial pace. Part of it was around distributed execution, which would now class as cloud automation, and running those high volume automated tests across a number of different locations. Equally, making that more robust. So that meant more error handling, pop-up handling, and scenario recovery. So as we see in the early noughties, we've kind of moved on to start looking at more enterprise level automation. You may be asking why this huge shift and why that the UI layer is no longer the main area for us to focus on when it comes to UI automation. First of all, most of you out there have been using Selenium or Selenium 3 to deal with the W3C compliant DOM UI automation. Now that's great, and I understand the value in what that brings to you from an acceleration point of view. However, even within a standard fragile UI, there is so many dynamic components which are much more difficult to deal with, including multiple containers and XPath locations which dynamically change. Using descriptive programming, fuzzy logic, and regular expressions, we can solve these problems. And some products like Eggplant and Zaptest have really looked at bringing things like OCR and image recognition back, which used to be classed as analog mode in the early days, to really help solve some of these problems across a varied amount of different platforms, especially when most enterprise applications aren't UI based. So partly that challenge has been moving away from understanding the layer which you see from a presentation point of view and testing the AngularJS framework which has been built, and actually get underneath the model view controller. Most enterprise apps that are developed today have the information at each one of those layers that you should be looking at concentrating your efforts on. Equally, what I'm going to show you in the demo now is how UI automation was still as fragile as it was back in the 90s. Okay, let's start with Selenium. I recently contacted the author and creator of the Selenium builder to see if we could recommission it, as it's no longer being developed. But it allows you GitHub integration and also the ability to export to different files types. So straight away we're using the automation page. I'm going to click on a few links. The Lehman Brothers page unfortunately is no longer there. I'll click on one of my previous projects, which was for Lehman's, where there's an image. I'll close that down, and now I'm going to record a verification. In this case, I'm just going to look at my current contracting status, and as you see, it picks up the standard text. Equally, I'm going to see if it can record some information. If I now change that information, new user, I'm now going to click on the login button and then click on demo. At this stage, you'll notice a couple of things. First of all, it's not able to edit in any boxes that isn't a DOM. New password, which is where you use something like AutoIT or something else to record and embed. Equally, when we move to an example page of something which is, say, Web 2.0, such as Flex, there's no interaction into here. So that is Selenium Builder. We can stop that. Okay, let's try that again, but this time in WinRAR. Now I'm going to resist the temptation of diving straight in and using the record tool, but as you can see, I'm able to look at information through the spy tool. Okay, let's try that again now with recording. that will not run next time based on autocomplete's now been told not to. So that covers off functional automation. Well, what about non-functional or performance testing? Well, when it came to performance testing in the 90s, Astra Load Test was the original before the famous Load Runner and now Performance Center. So what I'm going to do is take a bit of a glimpse into how things have compare and contrast. So this is a analysis that I've run on Astra Load Test recently in comparison to another one that I've ran within Load Runner itself. So let's quickly jump onto the VM. Okay, I'm going to load Astra Load Test, which for those who are familiar with Astra Quick Test, they will notice that this is very similar to QTP, which means we're going to be recording at a UI layer, or click and script as referred to in Load Runner. So what I'm going to do is I'm going to launch Fiddler at the same time to capture the messaging layer. So as it launches the site, the home site, and then we're going to navigate to automation.org.uk, I'm going to click on some various links. These links are going to return responses, which we will have captured in both of the tools. Now that I've shut this down and click stop, I've got a number of steps which it's emulating. I can export and save these sessions. So in this case, I'm going to export all the sessions, not to a curl script, but to a web test, because it's something that I can easily import into Visual Studio. Unfortunately, this version of Visual Studio does not support such files. So I'm going to run this now in debug mode, and it will click through the various different pages. And as you see, something very similar to what you would expect to see in QTP. Now I'm going to save that test. And I'm now going to launch the controller. Move across, create a goal, and then start. Now while that's running, I'm going to launch a similar one, which I've run more recently, which I did for the New Zealand Lottery Commission. Now what differs here is that we're still using Load Runner or Astra Load Test. We have site scope enabled, so we're getting information back from the various different counters, which you can see are on Unix-based machines. Now this was running 2 draws and comparing the difference in response times. And what you can see here is all the different actions. So we got login, log out, clicking tickets, and buying tickets. Now, as you can see, we've also got a master data file, which has synthetic data that's been generated with a number of different numbers that are going to be purchased. So if we scroll across, we can see that it not only has thinking time between it, but it also has a number of simulated numbers that there's going to be bought, and they'll be embedded within those scripts. So here's an example of a login script. This is using Flex. So you'll see that most of the requests and responses are in an XML string. That XML string was captured using reverse proxy. So the requests and response taken from the app server and the logging that was taken captured those XML messages, and I was able to capture real IDs and references and also timings between each transaction that was done. So that allowed me to create more realistic scenarios that I was able to run through with how real user behavior. As you can see, I've added a few ones that have various different ramp ups and ramp downs. And again, like high volume automated testing, you deploy it onto agents. Those agents then run. Obviously, from a perspective of the Astra load test, that footprint's much higher, which is why when we're using containers, typically we run it in headless mode in say a Docker container. Which leads me to some practical advice. All what you've just seen as far as using LoadRunner or Astra Load Test generates a C-like base language. Online, you can convert these scripts into something like JMeter, which is much easier to execute now using other tools such as BlazeMeter. Moving to the late noughties. This was my opportunity to run a global automation team and introduce a framework that spanned 3 separate regions. I had teams based in New York, across America, across EMEA, and also the APAC region. We had thousands of applications, and as you could probably expect, the demand for testing at the messaging layer was higher than ever. A lot of web service and SOAP based testing. So in this case, we really moved to focus on that API layer. And part of that was not just the logical, but the messaging and database layers. As you can see from the diagram, some of those technologies such as TIBCO, JMS, MQs at the messaging layer, and then having to deal with some of the back-end systems and databases, whether that be Oracle or SQL. And then at the front, we were picking up the logical endpoints such as REST and SOAP. At this point in time, I was lucky enough to be working with one of the leading guys in this area who built a website called Web Service X, a guy called Walter. He was a Microsoft MVP, and his examples were in a number of Microsoft training books around this service-orientated architecture. At that point in time, we utilized a tool called Web Service Studio to be able to go and do our request responses. However, typically now there is a number of different tools, including SOAP UI and built-in clients into your browser, such as REST client, that you can go off and send these request response pairs without having any thick client. Okay, let's give that a go. So first of all, the site that I mentioned, Web Service X, has a number of different examples. I'm just going to pick one, which is the one that asks about where your IP is. I'm going to take the WSDL, and then I'm going to launch a tool to do the request response. And to give you an idea of what that looks like in Web Service Studio, send the same request. And then moved back to request response. And then while I'm waiting, I'm going to type in, what is my IP address? Copy that across. I'm going to enter that value, and then I'm going to invoke which responds with United Kingdom as my location. I can look at the request responses here. So it's just been sent and it's come back success. Finally, it's worth mentioning that these request response pairs are worth holding on to, as this could be the foundation for service virtualization. And as you can see from the screenshot, we look at parameterizing that so you can create more sophisticated shims and stubs for your tests and also mock out certain services that don't exist. Episode 6, Return of the Jedi. Suddenly, everything starts to get much more complex, much quicker. Very much like the early 10s, where I find myself at a large commodity trading company, dealing with continuous integration, continuous delivery at an epic scale. Suddenly, there's much more teams, much more dependence on automation, and everything has to be built from continuous build to delivery to performance, all in the same environments. And this is kind of seen by this nice onion diagram here. In a continuous deployment landscape where you've got applications, services, data, and the model for deploying all of that. So suddenly we're getting much more complex for many different solutions under test. Equally, when we start talking about CI and builds, we start dealing with a huge amount of complex environments and different technologies that are dependent on it. Intentionally, the data here is not easy to read, as this is information from a snapshot of a number of applications that were sampled. What I'm going to show you now is how I deal with that kind of enterprise level scale by capturing as much information about the dependencies of a number of different applications and also environments. Okay, let's look at some of those master driver files that we used before. Okay, one of the top tips I've got for Excel is use XML as the native language for everything. So as you can see, the structure around information about the different adapters that are going to be executed and also the different environments have been stored in here. We've got a number of different environments with a number of different variables, and also if we go into the parameters section, we're starting to grab parameters, thousands of parameters from different systems, and this typically happens from some kind of configuration platform, such as your continuous integration platform. And we also have some dependencies on what configuration it is, what language it is, what country it is, to give it more context. So as you can see, these parameter files suddenly become huge. So if I take an implementation language like, for instance, Korean, suddenly I'm seeing the Korean implementation value for all or OK or cancel. Equally, when it comes to generating an object repository out of this, I can use this as the value to create a descriptive programming fuzzy logic parameter object. Equally, you can see how the tests suddenly have got more complex, whereas we're breaking down the different actions, and then within there a number of different objects that exist, and how we identify those objects will be within the object repository, which again is automatically generated by some type of asset scraper, which will scrape off each one of these objects and relates them to a particular window and also the object values, which could be in different languages. We also have definitions of classes and associated data. This data and tests can be mapped to a model. If I open up a model and look at a simple flow, such as the login process, which takes a username and password unless the user has forgot their password, of which they'll then go through an alternative flow. But it'll show the dependency between, say, a single sign-on login system, an alert platform, and then various different portals and applications which have multiple dependencies on this. So if I zoom out, you can get an understanding for a number of application dependencies. But if I just go back to the simple flow with login process, the data for that and the tests will be stored within the master test scenarios. That particular login process has a number of different components, equally associated data, and each one of those data would be in different languages. So if I look for one of these components, I'll be able to find out the help desk phone in multiple languages for multiple different customers with multiple different configurations. Equally, I can define the type of object class that that item is. Now, if I quickly jump into the code for each one of those actions for a particular adapter, in this case Ranorex and Flex, I can see that I have the code associated with managing combination box drop-downs, menu selects, etc. And also how I can do the parameter set and check for each one of these. This will give you an idea of the complexity around building frameworks, sometimes that are not necessary, based on the fact that most of the capability sometimes can be out of the box. For instance, if you were trying to do something similar within Python in Ranorex, etc. Other options include things like Telerik, which automatically integrates directly into Visual Studio and also in its own test studio. So you can swap between a development environment and a test environment. But the kind of what we were trying to achieve with something, say for instance TAS, the Test Automation as a Service project which we was involved with, which I demonstrated on an earlier episode, is making this as simple as possible for users. So in the case of users presented with a simple web page, that they be able to understand the relationship between, say for instance, objects and the relationship between tests. So in this example, which was built in Flex, in Silverlight, you can pick a market, a language, and then select a number of predefined steps as you saw previously with the login and then clicking a number of different other steps. But partly the difference between TAS and the standard approach was that we then would run those on a number of different machines. So this was the high volume automated testing running as a process in headless mode, so that you wouldn't actually need to have this running on a local machine. This would then scale up in a browser proxy and allow you to test more complex environments. Euclid, the example which we gave earlier around being able to deal with, say for instance, Flex, wasn't a problem, because what we do is we'd swap out the test adapter technology dependent on the end environment that we were trying to interact with at runtime. So in this case, it would use the Ranorex adapter through something to power Flex, whereas other adapters would be used if it was, say for instance, WPF or Silverlight. Equally, they could be Coded UI or some other third party. Equally, those results would come back to you through enterprise logging, so that you could understand what each agent was doing and what buttons they were pressing and executing. Now let's move on to the late 10s. This is when things got much more scaled again. So I was part of a global team for a £4 billion investment of operational excellence, of which 78 million was focused on test automation. Within the landscape of the bank was 2,700 applications, and as you can see from the pins, suddenly the global locations suddenly became much more scaled than before. Again, at an investment bank where we needed to be able to deal with so many different application types. Suddenly, that continuous delivery landscape increases in complexity once again, because we're trying to achieve a DevOps kind of approach. So we're talking about a model which we've gone through before and demonstrated, associated data, associated services, which on average were 26 upstream and downstream services per application as part of the ecosystem, and then a release pipe of which he was releasing that application into an or application ecosystem into an environment which had a number of application dependencies also in there, downstream, upstream, and downstream, and then a layer of automation over the top to test an entire complete picture. So suddenly things get much more complex, much quicker. Equally, going back before when we talked about how did we approach this, partly when you're starting to deal with things like SAP, which has a huge ecosystem and requires specialist skills, such as SAP consultants, suddenly these landscapes aren't always suitable for full UI automation. And that could be because most of the interfaces that you're dealing with, so for instance, XDocs for SAP, or the number of 700 interfaces you may have in an eSAP environment, are typically at an API layer and not a SAP GUI or SAP UI or SAP web page interface. So suddenly you have a huge amount of complexity associated with it, and also some environments on systems and endpoints are not accessible because of legacy systems, past mainframe support. At this point, I'd like to bring to your attention the YouTube link in the bottom left-hand corner. This will give you an example of a complete release automation pipeline. So pipeline as code, starting with your requirements definition or your stories in any kind of agile tool or requirements engineering tool, moving into the development phase, continuous delivery, continuous integration, moving into testing, service virtualization, test data management, performance engineering, to release automation. So then you've got your Docker, Chef, Puppet kind of landscape, releasing out into wherever it could be, the public or private cloud, and then moving into some type of APM tool to operate. Now I'm going to skip through quite a lot of this video, but I just wanted to give you a bit of a understanding of how all this stuff fits together in the real world. So this is going from a simple Kanban board kind of environment where you might have, for instance, performance test and also manual tests embedded in the same area. This end-to-end demo was done with my friend Keith, to then creating that in something like Agile Designer, which is what I've been talking about throughout this presentation. So being able to model it, and then once you've modeled it, be able to then export those tests back into your tool. So in this case, we're exporting all the possibilities of all the different routes through the application, and when we're saving those back into the Agile Central tool. And then what we'll see is those tools will appear within the test cases for that particular one, and which we can now run. Now what I'd like to be able to show is more around the automation side of things. So in this case, we're going into our release automation pipeline, and we're looking at deploying an application. In this case, this is broken into different swim lanes, and as you can see at the start, there's a number of steps that need to be completed, such as loading test data in, accepting stories, and then as those steps are executed through, you can deploy into the next environment. It'd be worth going through this in a little bit more detail when you get a longer period of time, because it includes not only just your standard builds, but it also features virtual services. So it also gives you your SV and NV. It also gives you some Docker examples of running Selenium scripts within a Docker UI. That gives you a context of how you can start doing headless automation, and also how your services, in the case of Lisa, are consuming those services, and how you can create virtual services to accelerate your testing. I will skip forwards to kind of give you an idea of some of the other tests that will be running. We have, back in our dev test portal, we have a number of tests at an API layer being executed, which aren't requiring tests to be there done by a real system. And as you can see the Selenium script underneath that again, and also how the data is synthetically generated on demand using our data on demand portal, and that can be fed directly into the pipeline and also into your virtual services. And then if we go further down, we can now see other tools such as BlazeMeter that will actually run and report the status of execution of doing performance testing, and then allow you to jump into the BlazeMeter SaaS platform to actually see what the overall status of the results was. So this is linking in unit testing, performance, UI, API, SV into a delivery pipe where you're able to get all the information feeding back directly into your test management or your application lifecycle management tool. Hopefully that'll give you a bit of a view of what the art of the possible is. Before concluding the 3 retro automation episodes, I wanted to introduce the latest blog that I've written, Legacy is Your Legacy. This was after standing up at Star West in California the other month and talking about world peace for automation. Partly that was introducing the concepts of everything being a node and then applying either learning, probing, test, or data to each one of those nodes. That way we could be independent on whether or not we're using it for performance, for functional, or other types of testing. We could abstract it a layer above the technology. So that way we can apply context around that to do more useful and effective test automation. Episode 7, the latest in the saga, continues. And partly what I wanted to do through this is talk about some of the ongoing challenges and the current challenges that most of you are faced with in the industry at the moment. Starting with the elephant in the room, which is DevOps. I've been talking about DevOps for the last few years and have a number of material around there. And partly when people start talking about DevOps, they talk about the changes in behavior and culture. I absolutely agree with this. Equally, I understand the underlying processes that sit there. So techniques such as MVP, minimum viable product, minimum viable experience, minimum viable delivery, or even minimum viable quality are all great processes to adopt culturally and also from a technology point of view. Equally, striving towards chaos monkey, failing forward, self-healing canary rollouts is something that everyone is aspiring to do. There's very few organizations that wasn't born in the cloud that have achieved this to a level of maturity which has seen the success. However, organizations that I've worked with in the past, such as Domino's, really are digital organizations that are adopting DevOps and have a high level of maturity. As you can see from this diagram, which is provided by Gartner, there's a lot more to it than just technology. And as far as we're striving towards infrastructure as code, platform as code, configuration as code, security as code, part of it is not just about the tools and technologies, it's also about the people. If anyone's seen my presentations recently in the last year, they'll have come across my quantum teleportation slide. This really was to say that it's shift X. It's shifting any direction at any time and jumping from one location to another. There's no need for silos anymore, and understanding and learning from each one of those environments is essential. Equally, learning from something like production and providing the insight of what customers are using, or equally to the left-hand side when you start talking about value-driven delivery, where you start understanding the requirements much earlier and defining what that value you're providing to your customer, giving quicker feedback, equally quicker feedback to the business, and also taking on principles such as lean to help us achieve this. One of my previous slides around where does the tester fit into this opportunity, as you'll see, there's a lot more overlap now between dev and test and ops. Our roles are starting to use the tools and technologies that are provided in both of those domains and also start leveraging them, whether that be monitoring or it could be measuring. When I move into a little bit of an example, and there'll be a number of demos throughout this particular episode, the example which I give is in a typical development environment. In this case, the code base is TypeScript, just for simplicity purposes. But what I'm seeing now to organizations is they're wanting to make quick change. So a button what might be labeled DevOps can change to TestOps within 60 seconds, very quick commit, very easy to go through, very lightweight testing, very lightweight release. Equally, you can understand straight away what the probability of any of these issues, potential issues it could be with deploying this, and part of it is you can visualize that and you can visualize the risk. So gone in 60 seconds, very easy, very simple. In this case, it's just a minor change to text. From a testing perspective, we're looking exactly the same thing. Part of it now is we've got a lot more understanding and bringing it closer, as previously discussed in the other episodes, around bringing it down to the code level. MVC, Model View Controller, really allows us to understand the relationship between things like large-scale architecture and the changes that are being committed to the system. Equally, things like the visual tree represent that change to the button, so we can understand what the DOM is straight away for our testing purposes. This typically would be as an XML output, which we can read as part of a post action before we start the actual test. So straight away we're using self-validating our test scripts in the content-driven validation, which we're talking about earlier on in the session. Equally, part of it is our build understands the rules, and it also understands the dependencies. As you can see there, from the validation point of view, the tests understand the context based on the code, and we're starting to click in closer to the relationship between requirements, code, and tests. Then when we come to actually execute those tests, whether that is a dev in test kind of tool using Visual Studio or Eclipse, or if this is something which is a model which is generating the artifacts out the back of it, these are all options based on now we understand the context much better. Equally, as we understand the context much better, we can also build a confidence around the quality or the testing that's being executed. I talked about DevOps and some of the DevOps success. There's an example here of a case study which I was involved with Domino's. The links there are on there to give you a bit of an idea of how this actually has happened in the real world. But first of all, I'm going to start with a simple demo. This demo is just an example of the type of technology which we used whilst at Domino's for delivering into the continuous delivery pipe. It's worth mentioning that Domino's have different technology stacks between each region. So as the UK was primarily a Microsoft shop, the other domains were completely different technology stacks. So it wasn't one solution that can fits all. Equally, it wasn't just one tool or one technology that was applied. Equally, culturally, they were different in each location. So this is an example of LeanFT. This was as part of its early beta launch over a year ago today, using Visual Studio 2012, and 2015 had been released at this point in time. So partly what we're trying to achieve through this demo is that to understand that we can run any of these, whether that be Telerik, LeanFT, under an NUnit, JUnit, XUnit kind of environment. So part of this is we've selected an NUnit because that's the kind of the target state which we're trying to do. We're wanting to be able to deliver it down the continuous delivery pipe. In the case of the organization, they started off with a simple Jenkins build with Octopus, moving to a more advanced Azure release automation cycle. What we're doing now is we're just bringing up the Domino's to site, and we're just looking at it from a simple object recognition point of view. So in this case, the SPI tool's fairly lightweight. It enables you just to look and query what the DOM reference is, but partly what we'll be doing in this demo is we'll be using descriptive programming to avoid using any kind of object repository or learning any of the objects. So I've selected the most simple component, which was the postcode, and then I've just highlighted across. So as you can see, the dynamic repository is changing as it goes through, and it's giving you the potential context behind. So in this case, XPaths, your analog locations, and tags that you can potentially use. Equally, you can pull this information back and paste this straight into into your Visual Studio. Equally, you can add that to a repository, which is an application model. That application model can link into whatever other tools you're using, whether that be Octane or ALM or some kind of source code repository system that you're using. In this case, we were primarily using Visual Studio Team Services and TFS 2015 SP3, which included the release automation components. So I've opened one up, and as you can see now, I'm using the ID tags instead of using a repository basis. So this just takes that dependency out. This is just a simple test to show how we can run this now in the Test Explorer, which would run exactly the same in NUnit. Now, part of this simple demo is really to prove two things. Is the first is the ability to use unit testing in the context of how do I build based on dependency of the browser, for instance. How can I do a continuous delivery in automation UI within the delivery pipe? Equally, one of the key components of this is also measurement. Is understanding what's been executed and look at the reporting. All information that you'd be feeding back into your CI tool of choice. In this case, as it's been a Microsoft platform, we're executing it in a Microsoft stack. Now, there's a lot of interesting things around the Dominoes application, which has been what has changed over the time. This is an AngularJS application, which was always a challenge to test based on the container model. At certain locations were hidden, which means that you couldn't see the actual containers that were sat in there. So this is just running on Chrome, very simply entering a value and then highlighting the nearest location. Partly what the challenges as we went further down, which is we moved into being able to use the same code to be able to test mobile and also be able to test the traditional application model. So this is just outputting some simple test results, and we should have got a pass that's come through. Being able to pass this result information up and send that or attach that to some kind of execution history is really important. And as you can see, this was executed back in 2015. Okay. The next demo which I'm going to give you is around wearables. So similar kind of challenge with Dominoes is we looked at how do we test an application from day one. So partly when it came to be the first on the Apple Store for the watch, we had to look at how we test this. Now in the case of gaining access to the SDK and test devices before launch, we were able to actually build our automation artifacts. So then on the first day, we were actually able to run automation tests on real devices and launch it into the App Store as quickly as possible. But what you're seeing with most application environments now is you're looking at building and testing on a mobile device, or as they refer to as mobile first. Here's a simple example running within a Eclipse environment where you'd be running against a number of different devices. Now, what's useful to mention in here is we're running the same script against two different operating systems. So we've got Android on the left and we've got the iPhone 6 on the right hand side. The reason why we tested it, we're demonstrating it with this particular application and not the Dominoes application, is because this gives us a bit of more context around how you deal with text testing something much more complex as far as containing graphs, containing metrics, containing information, dashboards, and also it's one of the challenges which we've got for 2016 is really demonstrating our ability to test for large-scale ERP, CRM based platforms where there is a move, especially with things like SAP HANA, to be able to test on multi devices, multi-delivery, and part of it is checking sure that that information, that such as business critical information, not the consumer market, is presenting the information in both places. And this is part of this much higher scale of release automation pipeline. Part of that pipeline is things are getting much more complex. There is environments which are Amazon, Salesforce, Oracle Cloud, and as I just mentioned around SAP, SAP HANA. We've got different database technologies that are sitting behind that now, where you're talking about things like NoSQL and MongoDB. You're starting to deal with more challenges around how you're dealing with continuous delivery and provisioning. These are all difficult challenges which organizations are dealing. So the release automation pipe is absolutely essential. So I'm going to move into a example for running the same test we've just seen, but now as part of a standard build. So in this case, it's just a Jenkins using JUnit, sorry, and TestNG. So part of this is it's running, and as you can see, as it executes on the right hand side, it's running on the devices, and it's going through and testing that sampling example application that we used for testing purposes. And what the good thing to note about this is part of unassisted automation is most of the time you can't see what's going on. Therefore, you're relying on good reporting and also capturing all the information that you possibly need to. So these are all your dynamic data adapters, such as how much CPU is being used on the device, what the memory is, what any debug information. So in our case, we have something called APM Mobile, which allows us to look at stack trace information for execution on different mobile devices. But equally, part of it is understanding that whole landscape of capturing as much information as you possibly can, so that way when you go in and you look at your results, you can see exactly what's been executed. So you can see the steps that have been executed, what the test steps were, what the data that was being populated in there, what the different activities that happened throughout that test. And this gives us a great reference, and also we can compare that against previous runs. Equally, we've got the video that comes from each one of those devices, which allows us to step through this step by step.
This leads nicely onto the digital experience bug that I've been working on over the Christmas period, because a simple flow through a mobile application will change depending on the persona associated, and this equally is more complex when it talks about digital personas. So whether or not you're a digital native will use an application in a different way across different channels in comparison to someone who is a digitally disengaged or digitally dangerous. So partly there is a lot more to think about than just a standard flow through the application under test. And now with digital could be across a different number of touch points. That could be IoT, that could be wearables, or it could be even across a connected car. So the example which I'm going to give next is about using the crowd to give you more unique, varied personas that come from real user base. So this example which I've got in front of you around a wearable application which was designed for a leading pizza company when they wanted to do the launch, we had to create personas around how people would use the smartwatch. This technology was then taken for other projects such as smart city projects where we use crowds with different mixtures of personas such as age range, gender, and also those digital personas that you saw on the slide before. This helped us build smart city applications. In this case, and the example which you're going to see following, this was a smart city application which used gamification to allow people to compete to reduce their carbon emissions for 2020. This tracked information taking your GPX data, so in case of a mobile device has a number of sensors, one of them being GPX, it take your historical route and recommend bimodal traffic and transportation options that would be the most carbon neutral. And then you'd compete in a large scale leaderboard based on your company or your group or your crowd. So In this particular example, which I'm going to show next, we had the challenge of how do we test a smart city application without historical information before the application went live. So in this case, we created a smart city data exchange, which was a big data base which allowed people to access, sell, and consume data, whether that be footfall information about local shopping centres or information around trends of users. So therefore, we needed to create historical transactions for 6 months and 38,000 users. This was done using the following demo, where we took some data provided to us by the students, which provided some deltas for the GPX data. We then synthetically generated, as you can see, the XY coordinates, which have now been inserted into the smartphones from our product called Test Data Manager. This was able to create 2 billion historical synthetically generated transactions, which were unique journeys through the city of Copenhagen, which you can see on the 6 devices on the right hand side. So as this started, you can see the devices actually moving around on the different platforms. So therefore, we could actually have phones giving real information that was synchronized with the application which was running in the background. That gave us the baseline of actually being able to test real devices, thinking that they're walking around the city like a normal user. Once you've started collecting all that data as part of that city data exchange, suddenly you have historical transactions, which you can then apply in machine learning, deep learning, and AI to start doing things like prediction. So part of this is then taking it to the next step. So Urban 4.0 talks about things such as predictive crime, which is one of the projects that I was working on. This visualization platform allowed to connect IoT devices, whether that be cars, cameras, buses, buildings, Twitter feeds, weather information, and then overlay that in a real-time system, and then apply video analytics to do predictive crime, apply algorithms for loitering or unusual behavior. Part of it is this is the next generation of testing highly complex smart city projects. And as you can see, there is a user interface, but as you'd expect, that those information would be better accessed at some kind of messaging layer or even at the big data layer, which could be something like MongoDB. So you're starting to deal with NoSQL, more complexity around lots of different feeds and where that information is coming from lots of different systems. Now on to containerization. One of the challenges, especially when it comes to service virtualization and network virtualization, so emulating thousands of devices, like what we've just demonstrated, and on the previous episodes we talked about using headless or mode for running automation within a container, such as Docker. The challenge around that is usually around the amount of memory and disk space that's required. Now, for the platform that we used for testing the smart city and also virtual power stations, we had up to 10,000 of these VMs running. How that was possible was we was using a UCP platform which had 96 terabytes of primary memory and 500 available CPUs, but also we considerably reduced the size of a container by using unikernel architecture, which brought it down to 16 meg on average and 88 meg for the actual footprint. So the hypervisor was able to create more of these instances which had what I would class as a micro container, which is a smaller container with just the necessary endpoints. So a microservice at the end, which is able to talk to the application, to the test automation controller to run those agents at scale. So high volume automated testing and high volume mobile testing. How this works is now native to Windows, Windows Server 2016, where Docker is actually built as part of Windows containerization. So you can leverage technologies like unikernel within a Microsoft platform, not just an OSS architecture, which is typically how Docker and Puppet Chef had operated before. So the example which we showed in the previous episode around doing the end-to-end demo, you'll have noticed that this had a Docker UI with a number of Selenium, Chrome and Firefox endpoints, or as you can see, what we class as nodes. Episode 8, The Forces of Destiny. This is the holding title for the upcoming Star Wars movie this year, and I've registered the domain below to allow you to download the slide pack. We're now going to go into the next generation of automation. So when we started, we talked about some of these concepts, about moving beyond the current automation for automation to write itself, so autonomics. Part of where we're going on this maturity level, or this automation maturity model index, is to look at how we move through the maturity, going from manually creating scripts to continuous delivery. Then at the level that we're at the moment, where we're talking about DevOps and digital engineering, and then we're moving into more lean engineering, talking about minimum viable product, delivery, quality, and then getting to the point where the automation is writing itself and it's deploying by itself, so it's fully autonomous. So as you see, we're shifting from the left-hand side, where we're very siloed in our thinking, and also we're not being lean as far as we're not reusing the SV, NV, and NFV, so the network function virtualization, service virtualization, and network virtualization across the entire teams and between silos. Equally, we're not using any of the historical transactions of what we're delivering from a continuous point to understand about the insight driven, about the risk associated with checking in or dependencies on different environments based on historical trends. Equally, this culture of DevOps moving towards IoT ops, SecOps, so security ops. At the end of the day, we're going to move past DevOps and it's just going to be no ops. So it's just going to be business as usual. People will just be doing DevOps by design, by default, and we won't need to worry about mentioning that we're going through this process. Equally, we'll be starting to see emerging self-healing environments and automated orchestration. So environments will fail forwards into different environments based on security risk. It might move between public and private clouds. It might morph off platforms such as SAP to Oracle and then back onto another CRM dynamically based on what's the best for the customer and what we're trying to achieve. Some of the technologies we talked about before, such as micro-containerization, much more microservice architecture, a lot more open innovation and connected intelligence, where you're starting to connect these items together. And as I'm going to talk about, some more of this kind of cognitive adaptive insight, so more learning from different systems and different components, and not shifting one way or another, but just shifting wherever it is needed. As mentioned before, this could be more around the cognitive adaptive adoption. So this is looking at things like on the left-hand side, the learning, the thinking aspect of it, which is going to be machine learning and deep learning, applying algorithms and artificial intelligence to improve what we're doing as far as reduce risk to the delivery or the technology that's evolved through testing. So this is where we talked about the pocketbook around digital assurance. I'm also going to mention afterwards around some continuous testing webcasts that we're doing around value-driven delivery and how we can approach this. And this really includes this design ops approach. So this think, make, check, which also has a number of different areas which we could go to in further detail. But I'm moving on. I wanted to just kind of highlight those at a high level. So how we move through that experience changes also based on the rate we're doing, whether this is core IT, trying to innovate the core, or this is some kind of adaptive, fail fast, learn rapidly type of environment. And that's really what I'm going to give you a quick demo about the rapid development component, which is this kind of quick digital evolution. Equally, I'm going to talk a little bit about this cognitive adaptive learning, so this ability to connected intelligence to connect everything together and learn from it, and also how you manage that from an assurance point of view. I'm also going to briefly talk about digital archaeology, which is how you go back into that legacy as your legacy and dig up the blueprints which represent your systems, which typically have been inherited from over many generations. And then once you've got that information, you've got this digital ecology, you've got this snapshot of all the organisms, your system as an organism, that allows you to understand it and be able to evolve it. So as I mentioned before, the design ops approach has a number of different dimensions to it, and that goes into the kind of design and learn aspect, proving the hypothesis, etc. And behind each one of these is a number of different components. And what I've done is I put together a bit of a digital manifesto, which explains these in further detail and how you can look and measure and monitor and understand what you're trying to achieve as part of your DevOps or digital attempt. So let me give you a bit of an example of when we're talking about this quick, rapid design ops. So we've got a simple model. We've talked about models all the way through here, but the model is actually based on some kind of wireframe. So in this case, as you can see, this is Microsoft PowerPoint, of which we built a model around what a proposed application needs to look like. And in this case, we're running Eggplant to actually be able to recognize that screen based on the screenshots that have been taken in PowerPoint and the actual application that's been developed. So this concept around the book chapter in experiences in test automation, around being able to do first day automation, create the flows before you actually have the delivered application, and then once you've developed the application, so this TDD, BDD, ATDD approach, then the artifacts that you've already generated and the flows that you've generated and the data that goes into those flows can then just run against that particular platform straight away. Equally, that's not dependent on what type of device it is, so it can understand how to apply that again onto something like a mobile phone as well, which we'll see in a second. But part of this technology is really how you can accelerate your design ops quickly into production. So this demo, when we've got an end-to-end demo version of it, actually releases this application through the release pipeline. It's just a standard MVC application which is designed as a demonstration. And as you can see, that person's logged in now after registering through that flow which we designed. So we actually can design the script that came out of the back of that, whether that script be Eggplant to start off with and then move on to something like Telerik or Ranorex afterwards, or even some kind of standard Selenium script. So moving on, we talked about the fact that the data digital archaeology component, so how we can start applying machine learning and artificial intelligence to actually be able to dig up complex systems and what's happening. So this is a lot around cause and effect modeling. It's about understanding where data is injected and request response as through various different systems to understand and discover, which is what I like to class as this node probe concept of systems that may or may not exist, or you may or not be able to understand where the data is, how the data is passed through the different systems, and then the different systems dependencies. And this allows us to accelerate things in a lifecycle virtualization, which is lifecycle virtualization is really around application virtualization, database virtualization, service virtualization, and network virtualization all coming together that allows you to bring an entire environment which doesn't exist early into the life cycle as these things evolve and change without actually having them from day one. This is kind of how we've talked about this machine learning kind of component, and I wanted to bring a practical example of this in the case of the bot framework, which I might have mentioned. So partly when I was working with a pizza-based company, they replaced their online help across multiple platforms. So that's Xbox. They also have an app in the car. They have a watch app. They've got social media, and they've also got legacy platforms such as a web page and a mobile app. if you wanting to talk to somebody, it uses a bot which then recognizes the context which you're explaining. So I'd like to have a pizza, or you might say to them, what's the best option that I can do for a family of four? And it would understand the context behind that. So part of that machine learning, as you can see from the picture behind, is actually it starts modeling that out. Once we've got that metadata, we can use that to actually drive our automation and that concept around node test and node learn. We've started really building out these models so we can understand the dependencies and relationship and context behind transactions and flows. So partly this next section we mentioned about the fact that it's the digital ecology. It's about understanding the relationship of all these applications, all these APIs, all these endpoints, all these paths through your application, which are those links between the nodes. Now this could be highly complex, especially if you've got systems which have been evolved over many years. So now we're looking at how we bring in this same technology to bring insight. So historical transactions, when things have failed, memory leaks, memory, stack overflows, things that have happened historically, and how we can look at changing those or predicting that behavior before it actually happens. So we're starting to build that into all of our tool sets across mainframe, the agile operations, and also the continuous delivery products. Again, this is done in a similar kind of way across all of our product sets. So whether or not we're using the connected intelligence technologies, powering a test tool or a development tool or a delivery deployment tool, each one of them starts to collect lots of information. So we're using this node probe to actually go and capture that information and log all that information, and then we'll put the pattern recognition, predictions, looking at using the analytics engines, and then providing some kind of insight based on what's happening. So this technology is something which is using things like Elasticsearch, etc., is best of breed for bringing AI into into the testing space. And part of that is this example kind of gives you a bit more of an understanding of how this all comes together. So this layer, which it's continuously learning, it is about your repositories, it's about your applications and how they're deployed, how they're released into different environments, and that environments underlining that is infrastructure management. So the actual physical hardware. It's about the data management, whether or not you've got challenges around GDPR. Part of that is taking that data, snapshotting that data, database virtualization technologies. So you've got that quick, rapid deployment of complex systems, but then at the same time you're probing those environments, you're probing the release, learning about them, reusing that data, powering your tests, and suddenly everything becomes connected. And at the same time, you're starting to get this insight. On the right hand side, we've got a freemium platform which we use, which is our app experience analytics, which tells you about how people are using your application. We plug this kind of stuff in at each layer so we can see what the developers are doing, how the users are using it in the development, in a test environment, in a performance environment, and we're able to do this whole APM view of the world where we're learning from production and validating that what we're doing in testing is realistic to our actual user patterns. Alan Page, who's the guy who wrote the book on how Microsoft test, when he did a podcast quite recently on Test Talks, he talked about the fact that what's changed in the industry is he gets this app insight coming within minutes and instead of hours and days where they'd have to collate this information, so they can understand how their users are going through journeys, where the system's having problems, where maybe if it was an Xbox, how it's dipping in frames per second on a certain corner at a certain temperature of a certain box, using Microsoft Operations Manager or some kind of platform that's looking at the hardware and the software, and they're able to take that stack trace information and pull that across and quickly debug it and also collate that information to say, well, actually it's 4% of our users are doing these particular activities causing these kind of problems, but also make sure what you're testing is realistic to what your actual users are consuming your application. And this is where we look at a much larger scale of things. We're looking at bringing that learning from ops, looking at pulling that information across. And wherever you see the purple round area is about reuse of all the technology that we're talking about today, whether that be the lifecycle virtualization technologies, or it could be about creating synthetic test data at those certain points, whether that be for a tool such as a non-functional tool like a performance within performance engineering, whether or not you're using that really early, about defining your non-functional requirements early on from a requirements engineering point of view, or whether or not you're modeling that or coding that and quickly making sure some lightweight performance metrics are put in place, or you're actually looking at what's happening in your APM tool sets to then look at what's actually happening in your performance environment to make sure things like network utilization are the same, that your load balancing is working correctly, and that same applies for using it for security and reuse across each one of those components. So part of it is we understand that it's not just a testing activity. Equally, it's not a siloed testing activity. It's about reuse across the entire stack, and it's also about understanding the landscape much better. And whether that be all the way from the design ops kind of point of view, where someone comes up with a concept and they want to prove that very quickly, and then they're using Chaos Monkey, or they're using some kind of method to allow you to understand whether and that is a good idea, or they're looking from a right hand side of saying, well, actually, we're seeing this kind of behavior and we're wanting to create or an opportunity or a new product from that. Part of it is we're having to look at all the different dimensions, not just testing in isolation or automation in isolation. All of what you can see here is powered by automation, and you don't want to hand crank that automation. That automation must be generated, it must be configuration, platform, infrastructure as code, security as code. Everything should be done as pipeline as code, so that you can reuse it, it can be regenerated, and it's not going to be requiring you touch points at each point. So finally, we look at that whole landscape of that continuous delivery workflow. We look at the different trigger points. We look at how we're involved from testing at each component, whether that be acceptance criteria, maybe it's the value-driven delivery stuff that should be going on earlier on in the life cycle, the requirements engineering kind of aspects or performance engineering, to your continuous delivery, your check-ins, to your containerization technology, how you do release management, how you measure and monitor success, how you look at the APM and the ops side of things. It's the real challenge of understanding the whole landscape. And what I kind of wanted to do at the end as kind of final thoughts is just to say that a lot of what I've talked about in the last eight chapters is some of the approaches that I've used within the last 16, 17 years of my career. However, these are continuously evolving. So the caveat is using these approaches in the same way and expecting the same level of success will change, and that will change based on a cultural area in a geo-based locations. Some will do much better to certain types of approaches. It might be based on the technology stack which is involved. Therefore, you've got to evolve your processes continuously. You can't expect the same framework to scale across all of the business. It has to be what works for that moment in time. Episode 9, the future. We have no idea what's going to happen in 2018 and 2019, and we're starting our journey into 2017. So what I wanted to do was introduce some things that might help you move forwards in 2017 for automation awesomeness. My first top tip is the Continuous Testing 101 webcast series that I've been working on and is now available on iTunes and also to watch on demand. These sessions will be recorded with my good friend Ray Arel, who'll be talking around solutions thinking, and Eric Simmons, who'll be talking about value-driven delivery. This first session with Ray Arel, who's globally known across the industry around the agile communities, will be talking about how you can apply business, technology, and usage together to get an understanding of what your customers are wanting and their requirements. The second one from Eric will be talking about value-driven delivery and how these come together to define what value means to your customers and your stakeholders. When we move into this next generation of things, we started doing a lot more around MR, so the multi-reality, which is a combination of VR and AR technology. So when you look at things like the Microsoft HoloLens technology, there's Pokemon Lens now, which is using that MR technology much stronger, like the Google Glasses was. We've also done testing on devices which you see in that bottom left down corner, which is the Samsung Beyond, which allows you to live stream 360-degree VR. We've looked at mounting these onto devices so that you can control them from an autonomous point of view, and that could be, as you can see in the top right and corner, that could be based on a drone technology. But once you've got that learning, you can start applying AI onto that. So I've talked to farmers in Australia who are starting to use that technology so that their drones can land themselves in safe locations by analyzing their surroundings. So look at finding that somewhere flat to land. So this technology is happening, but also the real world testing of it is. I joked at the last time I was presenting at the conference in Star West, and we talked about the Pokemon Go example, and this was a model which a graduate had come in and spent a couple of days putting together, modeling out Pokemon Go, and we then went through the billions of combinations that could potentially happen, including all the GPX data that's coming through. And this may sound like it's just a publicity stunt, but in actual fact, the real part of this was two things. One is this is just IoT. These devices just seem to be endpoints. We're also now starting to deal with more complex things, such as you can see, it's the surrounding area. It's the VR and AR combined that you're having to start applying more logic to these sensors. The headsets which you're talking about for Sony VR, that particular week, that was the launch of the Sony VR mainstream adoption. Dealing with testing those type of devices is much more complex and requires a different approach to the applications that have come before us. We actually used the model which you can see behind to do a joint webinar with Perfecto Mobile, who used the GPX technology we've shown you on the previous one for Copenhagen Smart Cities to actually be able to drive Pokemon on an application and physically walk around and catch them based on crowd testing and also crowdsourcing the information of where the Pokemon were. So these challenges can be solved by a simple graduate. They may look incredibly complex and they may be classed as impossible to test, but there is no impossible test. We have to look at new ways and new exciting ways to automate this process, because physically it'd be impossible to do this unless you roll this out to millions of users, which is typically the way that they test things, testing in the wild. So again, another little chapter from a digital book that I wrote last year, and this is around kind of digital engineering, around the whole challenge of understanding these new value streams, these new challenges within the industry, whether these be drones, 3D printing, VR headsets. These are the next generation of challenges that we have to face.